Hi there, intermediate algebra students. 9.2 is what's on the agenda for today, dividing monomials, and we talked about multiplying them. So here's another chart we'd like you to copy down. I'm going to explain it here briefly, and but make sure to get this chart copied down along with the examples. So monomials, of course, one chunk that it could be a number or variable or power, but the key thing, everything's multiplied together, no addition or subtraction, so one chunk. Now here we have two monomials. We'd consider the numerator and the denominator, and the idea is when we have powers, we subtract the powers. You might think that we divide them, but we subtract them. So for instance, this example, w to the 8th over w to the 2nd is not 8 divided by 2, which would be w to the 4th, but it's 8 minus 2. And we'll probably do something in class to illustrate that a little bit better why this is the case. But when you divide monomials, you subtract the exponents. Just like you remember when we were multiplying monomials that had exponents, we added the exponents. Alright, here's a key one here, the 0 exponent, and anything to the 0 power is always equal to 1. So even if it's just a variable or even a number or another conglomeration of things that's taken to the 0 power, it's always equal to 1. And next here's another important one, negative exponents. Negative exponents does not mean a negative number in most cases. It simply means that that exponent will be positive in the denominator. So here's an example here, c to the negative 3rd power, 1 over c to the positive 3rd power. And this applies to numbers as well, so we can simplify them as we'll see in our next example. Here's some examples we'd like you guys to try, so if you'd like to pause this video, write these down and pause the video, try them yourself, and then I'll go over the answers here in a second. Okay, first one, m to the 6th over m to the 3rd. Now maybe here's a helpful thing for me to write down why the answer would be what it is. You have a skinny marker there, I gotta double check that. Yeah, let's try that. Okay, so if I write down 6 m's, that's lots of m&m's, right? So there's 6 of them there, and then on the bottom I have 3 of them. I'm going to switch pen colors here. And I know that I can cancel out ones that are on top and bottom. So I cancel out all those 3 there, so how many are left? Well, there are 3 of them left. That shows you why you should subtract those exponents instead of divide them, as you might be tempted to do. Alright, next example. We have 16q to the 8th over 8q to the 2nd. Now I can't actually divide the numbers, or divide the coefficients as they're called. So 16 divided by 8 is 2. But then again, don't divide the exponents, subtract them. 8 minus 2 is 6. So those are kind of tricky trying to keep that straight. Next example, that 0 exponent deal. Remember, it doesn't really matter at all what's in the parentheses. As long as anything is taken to the 0 power, your answer will always be 1. Always be 1. And finally, the last example here that we have, 2f to the negative 3. I can break this apart, so I have 2 to the negative 3 times f to the negative 3. And the best way then to simplify this is, remember, this becomes 1 over 2 to the positive 3rd. And then this f to the negative 3 becomes positive in the denominator. So my super duper answer here would be 1 over, remember, 2 to the 3rd power is not 6, but it's actually 8. And then I have f to the positive 3rd power there. Kind of tricky stuff. We'll be working on this in class, practicing quite a bit. We'll be having an exit quiz as well. So get these good examples down. That'll set you up good for tomorrow. It'll be before Thanksgiving, so make sure you guys have a great Thanksgiving weekend, and cheer on the Bucks at the Dome, and have a great time with your family, and be grateful for everything that you have. Alright, we'll see you guys in class tomorrow, and farewell.